distance illusion. Imagine something catastrophic happened to the sun, and you, along with a few hundred lucky survivors, were forced to leave Earth in search of a new home in space to save humanity. If you decided to visit the closest star beyond our solar system, you wouldn't just fail. You'd fail so spectacularly that your entire species would be extinct before your spaceship even got close. When astronomers say a star is close, they mean on a cosmic scale. In fact, the nearest star to our solar system is Proxima Centauri. It's 4.24 light-years away. That may sound small, but for humans, it's an unimaginable distance. And unless we invent space-bending technology or teleportation, it's going to stay that way. We measure our lives in feet, miles, maybe a flight across an ocean. Space measures distance in light years, and that's where everything falls apart. It's a distance so vast that the human mind has no frame of reference for it. Light-year reality. Here's the thing most people get wrong. A light year sounds like time because it has year in the name, but it actually represents distance. Specifically, it's the distance light travels in 1 year. And light is the fastest thing in the universe, moving at about 186,000 miles per second. In 1 year, light travels about 6 trillion miles. That's 1 light year. Now take that insane number and multiply it by 4.24. That's how far Proxima Centauri is, roughly 25 trillion miles. Unimaginable distance. Let's try to put that into perspective. If you drove a car at highway speeds, let's say 120 miles per hour toward the nearest star, how long would it take? About 22 million years. That's longer than the entire history of humanity we know, longer than the existence of most species on Earth. Okay, so cars are slow. What about airplanes? Commercial jets fly at about 560 miles per hour. At that speed, the trip would still take around 5 million years. You'd have to fly continuously from the time early hominids first walked upright, and you'd only be arriving right now. Let's go faster. Let's use the fastest thing humanity has ever built, NASA's Parker Solar Probe. It's moving fast enough to circle the Earth in less than 3 minutes. Even at that speed, it would take about 6,300 years to get there. That's longer than all of recorded human history. The ancient Egyptians could have launched it, and it still wouldn't have arrived yet. And that's the closest star, not some distant, exotic target. If our solar system had a next-door neighbor, this would be it. And we still can't reach it with our fastest technology in anything resembling a human lifetime. Human speed limits. Okay, so current technology is useless. What if we somehow built something even faster? Let's say 1% of the speed of light, around 1,900 miles per second. At that insane speed, Proxima Centauri is about 424 years away, still multiple human lifetimes. You'd launch, and maybe your 9th-generation descendants would arrive, assuming everything goes perfectly, and your ship even survives reaching that speed in one piece. And here's the real problem. We don't have anything that can move at even 1% of light speed, not even close. Getting to 1% would require some kind of alien-level propulsion system we clearly don't have, energy sources we can't generate, and materials that can withstand forces we don't know how to handle. It's not just hard, it's currently impossible with everything we know. Fastest technology. So why don't we just focus on finding a way to go faster? There's no point, because physics simply won't allow it. Light speed is the universe's speed limit, and it's an unbreakable law. Nothing with mass can reach the speed of light. Not rockets, not spacecraft, and not you. Here's why. As you accelerate, you gain energy, and that energy adds to your mass. The faster you go, the more massive you become. As you approach light speed, your mass approaches infinity, and to push an infinite mass even a tiny bit faster requires infinite energy. Infinite energy only exists in video games and science fiction. In reality, you can't harvest it, you can't generate it, and you can't store it. If we could even do this in a simple, primitive way, we'd already be using lightning as a free energy source. So, light speed isn't just hard to reach, it's impossible. It's almost as if the universe has locked it behind a wall we can't break through. Naturally, that makes some people think about the simulation hypothesis, but that's a topic for another video. Anyway, the best we can hope for is getting close, but close still means decades or centuries of travel to get there. Deadly space. Let's say, despite everything I've just explained, you decide to go anyway, and you somehow solve the energy and propulsion problem. Your ship could travel at 10% of light speed, which would get you to Proxima Centauri in about 42 years. That sounds great. Now you just have to survive the trip, but space does not want you to survive. First, there's radiation. In deep space, you're bombarded by cosmic rays, the high-energy particles that rip through everything. Over years or decades, that radiation destroys cells and eventually causes severe cancer. Shielding helps, but perfect shielding is heavy, and weight is the enemy of speed. You'd need walls several feet thick made of lead or water, and that would make your ship so massive. Then there's temperature. Space itself is extremely cold. In direct sunlight, exterior surfaces can reach around 400 degrees Fahrenheit, while in shadow they can plunge to nearly minus 330 degrees Fahrenheit. Your ship has to manage these extremes constantly, or it cracks, warps, and fails. And then there is one of the biggest nightmares for spacecraft: micrometeoroids, tiny particles of dust and rock moving in space at high speeds. At 1% of the speed of light, a grain of sand hits your ship with the energy of a high-caliber bullet. Your ship isn't just flying peacefully through space, it's flying through a minefield where every single particle is a potential catastrophe. Life support limits. Okay, so the ship somehow survives. Now what about the people inside? How do you keep humans alive for 42 years even if you're lucky enough to go at 10% of light speed, or thousands of years if you're stuck with current technology? You might be thinking about sci-fi sleep pods as a solution, but in reality, we haven't truly figured out how to make that work yet. You need food. You can't pack enough for a multi-decade journey, so you'd have to grow it on board. That means hydroponic farms, artificial lighting, water recycling, and waste management, all of which require energy, space, and constant maintenance. If the crops fail, everyone starves. If the water recycler breaks, everyone dies of thirst. And then there's psychology. Imagine being locked in a metal tube with the same group of people for 42 years. No new faces, no change of scenery, no escape. You'd see the same walls, eat the same food, and do the same tasks every single day. It would be like a prison drifting through space. Long-term isolation studies show that people break. They get depressed, paranoid, and aggressive. Relationships fall apart, then conflicts escalate, and there's nowhere to go to cool down. Robot challenges. Okay, forget humans, they are too fragile. What about sending robots instead? No need for food, oxygen, or psychology. Just like we do today, build a probe, point it at Proxima Centauri, and let it fly. Problem solved, right? Not quite. Robots don't need food, but they still need energy. Solar panels become useless once you're too far from the sun. Nuclear batteries decay over time. If your probe runs out of power halfway through a 6,000-year journey, it's just dead metal drifting through space. At that point, it's not much different from Voyager 1. Even if your probe survives and reaches Proxima Centauri, it has to send data back. That data travels at the speed of light, which means it takes 4.24 years to get back to Earth. So if you launch a probe today, it arrives in 6,300 years, takes pictures, and sends them back. Those pictures arrive another 4.24 years later. By that point, humanity might not even exist anymore. Even if the data makes it back, who's going to care? The people who launched the mission are dead. Their civilization might be dead. The data arrives to a species that has moved on, forgotten, or collapsed. The mission succeeded, but it doesn't matter. Cosmic perspective. So, it seems we can't visit the closest star. We can't even send robots that will return useful data in a time frame that matters. The universe is too big, physics is too rigid, and humans are too fragile. But who knows? Maybe we're wrong. Maybe someone figures out warp drives or wormholes or some other trick we haven't thought of yet. But realistically, no one watching this video is likely to ever live to see it happen. If you liked this video, don't forget to subscribe. I'll see you in the next video.